So today we're going to talk about geology and energy. You see, in geology, we have three basic types of rocks. And those would be those rocks that are formed by heat and fire. You have a name for those? Igneous, fire, igni. Sedimentary rock. Rocks that are formed by water, erosion processes. Those are sedimentary rocks. And then we have those rocks that are formed by heat and pressure. Those are called metamorphic. Meta means in the middle of, and morph, to change. So they kind of change their composition or change their shape based on the heat and the pressure around them. So we have those three kind of rocks. And from that, you often get the idea, or you might get the idea, that all rocks are very different from each other. In reality, they aren't. The rocks in this area that you're looking at, or the rocks on this table, are all made of the same thing. Yeah, they're all basically sand. Sand is made up of silicon dioxide that bonds together and makes up large chunks of mineral that we call rock. And when it's formed by fire, in big chunks of rock, we call it igneous. As it breaks down, we call it sedimentary. And as it's reformed, we call it metamorphic. And that makes up a rock cycle where the igneous can become sedimentary, the sedimentary can become metamorphic, or anyone can become anything else. So let's talk real quickly about what those are and see how energy changes there. So this example right here, from this side of the table to right here, these are all igneous rock. Okay, so if we take a look at what's around us, look around you, and if you see, you'll see this is a really common kind of rock, kind of a black rock. Chunks of rock in your driveway, gravels. Yeah, here's a gravel, look at that. Yeah, look at that. That's called basalt. Basalt is an igneous rock. It's lava. It flows out of a volcano. It flows out across an area and then gets hard. And if it gets hard really quickly and fast, it gets real shiny, kind of like this black rock right here, which we call obsidian. Or if it cools a whole lot slower, it starts to form rock that starts to look more like this, which we might call gneisses. Or it can go through several changes, create an igneous rock like this. This is basalt, but it's little air pockets. And then the air pockets fill in with pure mineral material, silicon dioxide sands, which when they're clear, we call them agates. So you can see kind of through these, they're kind of clearish. Those are agates. These are all agates, and they just form in these little pockets right here. And as the rock falls apart, they fall out on the ground. But those are formed by igneous processes as the rock cools down and separates out these pure sand. But what's this rock here made out of? Still silicon dioxide. That's sand also. So different temperatures and heats make rock look different. So a rock that's formed down deep and cools really slow, like maybe in a pocket here, will be kind of clear. As it's formed closer to the surface, cools a little faster, it won't be as clear. And if it cools really fast and has a little bit of impurity, it might be not clear at all, but totally opaque. And that's a jasper. So we have jaspers, and we have different forms of quartz, which is silicon dioxide. All these rocks are quartz. And then we have agates, which are really clear. Okay, these rocks are formed by fire. So that means they were in the ground, the fire got them, as they cooled, they welded together. So is that a lot of energy or just a little bit of energy that went to making the electron bonds that are holding these rocks together? Lots of fire, lots of heat, a volcano, lots of energy or not as much energy? Yeah, that's a lot of energy. So that means the energy to break these rocks, or the energy released as they break, is going to be high. In fact, as you break a rock like this, it might even give off a spark. Or when you strike it with a hammer, it might give off a spark. Okay? But they don't break very easy. It's hard to break, and they could give off sparks, lots of sound. You can smell the smell of matches. And you certainly hear a lot of really high, nice tinkling sounds. That's high energy bonding that makes that high tinkling sound. So these have high energy right here within the rock. As we move to the sedimentary rocks, like these right here, you'll notice that they're kind of grainy. You can kind of see sand grains in there. Can you see those sand? Here's some, look at this, sand grains in there. They're like, almost like cement, you know, like, oh, look at this one. You can see, look at all these little rocks inside the other rocks, all glued together in there. It's like cement. Nature's cement is sedimentary rock. So water is going to glue pieces together. Well, how do we get these little particles? Oh, that's pretty simple. I just take a rock, and I'm going to take this rock and hit it pretty hard to break off a piece here. So I'm going to put on my safety glasses. I'm just going to put it up here, and I'm going to hit it kind of hard. Oh, look at the table right there. See all these igneous rock right here? They're not igneous anymore. They're now sedimentary. Are you kidding me? What? Yeah, it's the particle size of the rock that determines whether it's igneous or sedimentary. It's not what the rock's made out of. It's still made out of the same stuff as this. So what if I took this rock and I could knock a little chip? I'll take one that's not polished, and I could knock a little chip off the edge of that. Oh, look at that little powder and those little rocks. Yeah, that's now sedimentary rock, even though it came from an igneous rock. It's just particle size. So that's sand. Sand is sedimentary. Sand is silicon dioxide, just like glass. Wow, that's amazing. So how does it get into this form then, where you have these little sand particles? Well, all it takes is water kind of layering them together. And as it layers them together, it can make mudstones. Flat, soft. Look at that. My hand's turning white from all this stuff coming. Can you see the white, chalky, powdery stuff? Look at that. These are mudstones. Okay? And that's just simply sediment like this that kind of got laid on the ground and built up. Now, can you see that in here? Yeah. It's like black sediments, white sediments, gray sediments, all kind of cemented together inside these rocks. That's sedimentary rock. This one looks like a bunch of sand wound together, and it's called sandstone. It's harder than mudstone. Mudstones are pretty soft. Sandstones have been through a little more heat and pressure, dried out a little more, maybe have a little more calcium or cementing materials in them that hold them together. And so as a result, they make up a much harder rock. So this rock seems pretty hard, but it doesn't take very much to break up a sedimentary rock, because the energy that put it together was just water and laying down in a pile while pressure came on. And lots of materials and pressure kind of glues them together like glue, but it's not a lot of energy. So these rocks break apart pretty easy. You can just see me rubbing off sand grains, right? I had to hit this rock to get sand grains off, but I can just rub them off now. Look at that. Little grains all over my hand. A lot of times, they just break off. Look at that. Oh my goodness. What a wimpy rock. Wow. That's because there's no energy in the bonds, because it didn't take much energy to form it. But they always break down into less organized forms. So they go from order to disorder, and energy goes from high areas to low areas. And so eventually, as it breaks apart, you can maybe hear it. You can maybe even feel some of the intensity of it as you're breaking it, so you can tell how strong it is. But eventually, you're releasing heat also as it breaks. And heat is the lowest form of energy, and all energy eventually becomes heat. But it's never lost. It's always there. So as the rocks all fall apart eventually, at the nuclear level, the energy is converted to heat. So how do I go to get these back together? It takes energy to put them back together. So I could remelt them in the earth and make another igneous rock like this beautiful agate right here. If it's a clear rock, has the most energy and was formed deeper in the earth and cooled slower. If it's a translucent rock, that you can just sort of see through, light will pass through, but you can't see through it, then that means it was formed a little higher, has a little less energy, it'll break apart a little easier. But if it's a rock that's opaque, that means it was formed with a lot of impurities in it and generally a little closer to the surface. Energy, high energy, low energy. So what about these rocks right here? These are metamorphic rocks. Metamorphic, remember, meant in the middle, meta, in the middle, and morph, shape. Well, it means that it's going to take a shape that's somewhat a mix of igneous and sedimentary. So you're going to take rocks like this, if I can put it underneath huge amounts of pressure and just lots and lots of pressure, kind of flatten it out. Pressure's energy. It makes heat. The molecules, as you put more pressure, might vibrate a little more, create a little more heat. It'll start to make layers, and pretty soon you get layers of rock. And those layers tend to become the metamorphic rock. Now, what were all these made out of? They were all made out of sand. But the amount of energy they have determines what they look like and how strong they are. So let's think real quick here. As you're about to go out and collect a bunch of things on the beach and see if you can figure out if they're igneous or sedimentary, or metamorphic, think about this. Where would you want to build your house? Is there any value in knowing which rocks are the strongest? If we were on a beautiful beach, would you want to build your house right here on sedimentary rock, especially if it was just sand that wasn't yet cemented together? How about mudstone? Gets wet and becomes like clay? Or sandstone, that's quite a bit harder. That's hard enough that you could probably put a house on that and it would stay there for a long, long time, like our big cliffs around our headlands. But the most solid rock are the ones with the highest energy. So in sedimentary, it'd be sandstone or igneous rock. So you're going to go out and collect a bunch of rocks and you're going to identify, are they igneous or sedimentary or metamorphic? And for the most part, if they're super smooth, you can't see sand grains, that's igneous with high energy. And if you see lots of sand grains in the rock, or often lots of layers that have been compressed, that's going to be sedimentary. Remember the three types? Igneous, formed by fire. Sedimentary, formed by water and erosion. And metamorphic, formed by heat and pressure, pushing rock pieces back together.